Hello everybody, our staff, our affiliates, our resellers, and our customers and prospects. I'm happy that you have joined us in our SolidCAM World 2021 Q4 Summit, and we promise you will enjoy it. So let's start with my keynote speech. First, as you see in this first slide, we have a new tagline that SolidCAM is the software platform for CNC manufacturing. Why do we say that? Let's go further. Okay, let's see today the range of products we offer today. Most of them are available and some will be available soon. First, we have our great CAD integrations in SolidWorks and Inventor, and there will be more integrations. We have launched our shop floor editor and simulator for CNC operators, a very useful tool for the operator. And we have integrated SIMCO Edit for the edit of G-code and simulation of G-code. And I could promise you that will be coming, hopefully soon, SIMCO Complete Machine Simulation. Also, we have now what we call Solid Mold that includes RMB products, SplitWorks, MoldWorks, ElectrodeWorks, all integrated in SolidWorks for mold design and electrode design. And we have two new products that I will explain later. Solid Flow for optimal scheduling of CNC jobs, and Solid CNC, interactive marketplace for CNC machine jobs. These last two products, we have decided to go into them because we realized that you as a CNC machine shop owner or manager need these products. You need Solid Flow to get better scheduling of your CNC jobs, and I will be explaining that. And you need Solid CNC to get people who will give you jobs for your machine shop. So what we say is the future of SolidCAM is not anymore just CAM. SolidCAM aims to provide an all-in-one software platform for CNC manufacturing that connects CNC machine shop processes with the best CAM in the market, SolidCAM. Just to remind people, or if you are seeing us for the first time, SolidCAM has today a complete integrated CAM solution seamlessly inside SolidWorks. We have our basic model of 2.5D milling, you see it in the center, and then to the left you see our 3D milling modules, HSR for roughing, HSM for finishing, and HSS for surface finishing. Obviously, we have our great technologies, iMachining 2D and iMachining 3D, a must for every customer, and I will explain more about it. We have to the right, you see our 5-axis simultaneous and machine simulation capabilities. Our turning, advanced mill turn and switch type. As you know, we have the best solution today in the market for these two categories, advanced mill turn and switch type. And as you see on the left, we have also our product, Solid Probe, that is useful for any machine shop using probes. So we say that SolidCAM is the one CAM solution for all your CNC machine, starting from 2.5D to 3D to 4-axis indexial, 5-axis indexial, 5-axis simultaneous, and advanced mill turn and switch. And as your CNC machine becomes more complex, we give you more customer value to be able to get your CAM programming done the fastest and the easiest. A short review of our company today worldwide. We have today 244 staff, our own staff worldwide. Located in our headquarters, we have 2 offices with 60 staff. SolidCAM GmbH is our European headquarters in Germany with 7 offices and 70 staff. We have our newly established SolidCAM Spain for 10 staff, and we have our international support team in Serbia with 8 staff. We have also affiliated companies in Europe, SolidCAM UK, SolidCAM France, SolidCAM CZ, and SolidCAM Italy. In North America, we have SolidCAM Incorporated, handling both US and Canada with 35 staff. In Asia Pacific, we have SolidCAM India, SolidCAM Japan, and SolidCAM China, and affiliated companies, SolidCAM Australia and New Zealand, SolidCAM Singapore, SolidCAM Korea, and SolidCAM Taiwan. And also, in addition to all the branches and affiliates, we have a worldwide CAM distributor network of 65 major resellers. So as a complete picture today of SolidCAM worldwide, we have 22,000 SolidCAM industrial seats, 55,000 SolidCAM educational seats, and as I mentioned, a worldwide CAM distributor network with 65 major resellers, 7 branches, and 9 affiliates. You see here an example of our SolidCAM international customers. For example, in aerospace, we have Rafael, Dornier, Airbus. For automotive, you see Daimler Chrysler, Volkswagen, Nissan, Kia, Hyundai. We have customers in machine design, electronics, medical. For example, you see in the middle, Boston Scientific. This is one of our biggest customers in the US. They are a very big customer of SolidWorks, and they have about 20 seats of SolidCAM, and they were our first customer in North America. We have customers in optics, military, consumer, energy, production shop, mold tool and die, prototyping, and technical education. So SolidCAM customers today include both small and medium-sized job shops, medium-sized engineering and manufacturing companies, and large aerospace and automotive companies. Now I just want to talk about our integration. This is our strategy that led us so much success. When we decided that we are not going anymore to develop our own CAD system, we had a CAD system in the past, and we decided to integrate in the famous CAD systems available. So we have integrated in SolidWorks in 2000, finished our integration in 2002, and we got our gold certified partner in 2003, and we have also an OEM agreement with SolidWorks since 2003, where we could supply you with a complete CAD/CAM solution with an OEM of SolidWorks and with SolidCAM. So if you look at the first 2 rows, these are the only 2 companies that are integrated in SolidWorks, but they don't have their own CAD system. If you look at rows number 3 and 4, you have 2 CAM companies, Hypermill and Mastercam, that they say they are integrated in SolidWorks, but basically they push their own CAD system. You see, the mistake they made is they were having 2 parallel products, their own CAD system with CAM, and then another system integrated in SolidWorks. So what happens if you have your own system, you put your major development in it, what happens in the integration with SolidWorks version wither away. So practically speaking, you can never find anywhere a happy customer using Mastercam integration in SolidWorks, and Mastercam always push the version with their own CAD system. So today, if you are a customer using SolidWorks already for design of jigs and fixtures and other small designs, and you want to continue in the same environment, SolidCAM for you is the ultimate and perfect combination with your SolidWorks, because it's seamlessly integrated and you feel you are working in one system, SolidWorks and SolidCAM. Now I want to talk about our great SolidCAM eye machining. This technology provides unbelievable cycle time savings and unmatched tool life extension. Maybe many of you have already heard about this technology, maybe some don't, so I'm going to make a short summary of this technology. As you see in this slide, we have 2 versions of eye machining 2D for prismatic parts, and eye machining 3D for complex surface parts. What are the advantages of eye machining 2D? First, increased productivity due to shorter cycle time savings of 70% and more. You have dramatically increased tool life, sometimes as much as 5 times, even more. The tool lasts compared to regular tool paths. You have unmatched hard material machining. Actually, for eye machining, the harder the material, the more the savings. You have also outstanding small tool performance, and this is very important for different kind of industries. You can use eye machining both in 4-axis and mill-turn, and we'll see some video on that. You have very high programming productivity and very short learning curve. So let's look more in depth on eye machining. Eye machining has 2 modules. First, to see on the left, the intelligent toolpath generator. It calculates morphed spiral toolpaths, which are the most efficient toolpaths, and always it ensures constant mechanical tool load on the tool while it's doing its cutting. On the right, you see the second module, the technology wizard, which is unique in SolidCAM. It calculates the optimum cutting conditions for any given point on the toolpath. So what is the input that the user gives to eye machining? You just define what is the minimum cutting angle you allow and what is the maximum cutting angle, let's say between 10 and 80. So while the cutting tool is working, the cutting angle varies according to the situation between the minimum and maximum. And as the cutting angle varies, the feed is also varies. For example, you see 2 examples. To the left, you have a high feed. So we have a small cutting angle, so you have a high feed. To the right, you see the cutting angle has increased, so the feed has reduced. So always, this are varying along the toolpath, the cutting angle and the feed, but always the net result is constant load on the tool and constant spindle load. This is the unique character of eye machining. Let's look at 2 additional patented unique features in eye machining. To the left, you see our morphing spirals. These are spirals that take the shape of the area below it. It morphs itself to the area below it. And the second feature is our intelligent separation in eye machining using toroidal toolpaths. Let's see an example here. You see here, for example, this area had to be machined with eye machining, but it couldn't do it with one morphed spiral. So what happened, as you see in the blue, the toroidal toolpath divided this area into 3 sub-areas, and each one of the sub-areas is machined using morphed spiral. So the target of eye machining always is to do the maximum of the cutting using morphed spiral. Let's see another example. Here we have an electronic packaging part. You see, we start with a morphing spiral in the center, and then we meet this into 2, I call it islands. What happens? We do a toroidal toolpath around them to separate them, and then we continue again using morphed spiral. Again, remember, we want to do maximum use of morphed spirals. And then to the left, we meet again an island. So again, we separate it by doing a toroidal toolpath around it, and we continue like this, trying to do maximum morphed spirals. With eye machining, we not only do the roughing, but we do also the rest roughing and also finish. So eye machining 2D is unique that it completes the whole process for prismatic parts, roughing, rest roughing, and finishing. Here you see an example of an aerospace part, I think, where we see each one of those pockets was done with combination of mainly morphed spiral and with some toroidal toolpath. Let's see here an example of actual cutting in a prismatic part. Okay, here we see the material cutting starting. See how deep is the cut. Usually in eye machining, the cut is always maximum depth. Now, the tool is trying to get into the depth, full depth of that pocket, and then when it reaches the bottom, it will start doing the morphed spiral cutting of this hard material. The speed that it works, you think it's aluminum. No, it's stainless steel, and you see the maximum speed at which the tool is working. And you see the chips are always the same size. This is a trademark of eye machining. Eye machining also can be used not only for 2.5D prismatic parts, but as I said also before, eye machining can be used also in mill turn. Let's see an example of a medical cutting in a mill turn using also eye machining. This material in this case is aluminum, being cut on a Mazak Integrex machine at a medical customer in Germany. So it starts with just simple turning. Here, you see, it's doing the eye machining toolpath in 4th axis. You see again the chip size trademark of eye machining. Always the chips are of the same size. Here again, it's doing eye machining of like an open pocket, not a closed pocket. It starts from the outside with a toroidal toolpath. Usually when you have to cut an open pocket, you start with the toroidal. And now it's doing again morphed spiral. So it's always a combination of maximum morphed spiral with some toroidal. Again, here you see more spiral cutting. So, we've talked about eye machining 2D. Now I want to talk about the second model of eye machining 3D, that utilizes proven eye machining 2D and technology wizard algorithms. Actually, eye machining 3D is so amazing that it can reach sometimes 90% saving. And by the way, eye machining 3D can be used for both 3D surface and also prismatic parts. If you have a prismatic part with a lot of pockets, you could also do all the roughing and rest roughing of these pockets using eye machining 3D. Eye machining 3D does optimized machining at each Z step. And it starts by doing deep roughing using the whole length of the flute. And then rest material machining is done in small upward steps. Let's look more about how eye machining 3D works. So basically, eye machining 3D does optimal Z-slice machining. It does slices all along the height of the 3D part, and it achieves shortest possible cycle time by combining all these Z slices. It always starts, what I said before, with deep step-down roughing. It takes the full depth, first generating the roughing toolpath, as you see here, in this type of pocket that has different slopes on both sides. So first starts with the roughing, as we see here, and then it does scallop-driven intelligent step-up. If you see at these two slopes, they are different. One has higher slope, one has less slope. We do it per slope. Step up changes dynamically to maintain same scallop throughout the operation. So as you see to the right, this sloped face was done using only 3 steps because it has a higher slope, and the one to the left was done with many more steps. But always the scallop is constant. And this scallop value is usually set by the user, and this is important parameter in the calculation of 3D eye machining. The smaller the scallop, obviously, the more calculation time for eye machining 3D. And again, when you do the step-up procedure, the axial depth of the cut gets smaller as you go upwards. Every time a new higher step is machined. And eye machining increases the feed and engagement angle of the tool paths that machine the higher steps. As a result, the machining time of each higher step is shorter than if it had been done without the feed and angle increase. Another feature of iMachine 3D, negligible repositioning, achieved by optimal toolpath sorting and 3D Z-level linking. Nearly no air cutting at all. It cuts only where needed. And again, the wizard is working here at every one of the slices, and the cutting conditions are automated to maximize performance and efficiency. And we have always tangent lead-in, lead-out arcs, enable smooth motion, allowing for faster, more efficient machining, and this also increases both tool and machine life. Now, let's see more how the technology wizard works. We see here all the parameters that really have to be taken into account when you calculate when you want to input the feeds and speeds. First, all the material properties of the material you are cutting have to be taken into account: the cutting speed, the hardness, maximum step, minimum step. All the parameters of the cutting tool, the depth of the geometry, all the parameters of the CNC machine, maximum speed, maximum feed, maximum power. So basically, for somebody trying to figure out what is the optimum feed and speed, taking into account all these parameters is nearly mission impossible, and you need a lifetime of experience to be able to do that well. And even after a lifetime of experience, suddenly you meet a new type of material that you haven't cut before, and you are again stuck, and you have to go and do trials and errors. With the iMachining technology wizard, we automatically take the guesswork out of setting how fast your CNC machine should spin and feed the cutting tool. And we adjust the stepovers and how deep to cut. So as you see in the circle figure in the bottom, the wizard takes into account the material properties, the geometry depth, the tool properties, and the machine properties, and calculate automatically the optimum feeds and speeds, and also the depth and stepover. Obviously, as input to the iMachining wizard, we have to feed in all the material and machine databases that have all the parameters of these materials or these CNC machines. The only control you have over the wizard is you can tell it at how powerful it will work. We have levels from 1 to 8. There's a slider. So if you want a minimum material removal rate, you give it level 1. If you want a maximum metal removal rate, you give it level 8. So basically, if you are cutting a new part, probably you start with level 4, get the feeling of it, and maybe later you go to the maximum level. So this is the only thing you need to control when you are cutting with iMachining. Another feature, important feature of iMachining always is we cut with the full depth of the tool, as you see on the right. So this eliminates vibrations, and also the tool gets worn out evenly all along its depth, as opposed to the cutting to the left. When you cut with small depths, only the tip of the tool is worn out. And by the way, iMachining has patents, and we are protected by these patents. And we have many patents, as you see here on the left. So all these technologies we developed, the wizard, the morphing spirals, the separation, are protected by patents. Let's see actual results at customers. Here is an example of iMachining 2D savings in aluminum at a customer. The depth of cut was 38 millimeters, and the standard cutting time, when I call standard, is with like offset style toolpath as opposed to morph spiral in iMachining. You see, iMachining reduced the cutting time from 17 minutes to 6 minutes, doing 65% saving, and the customer had to do 400 pieces, so he saved 73 hours, 20 minutes in cutting time. Here an example of iMachining 2D saving in titanium. Again, the time of cutting was reduced dramatically from 17 minutes to 3.5 minutes. 80% saving. As I said before, the harder the material, the more savings is provided with iMachining. Here's another customer doing both iMachining 2D and 3D, and he says it was just amazing. For all components, they now achieve savings of 65 to 75%, as you see in the example here on the part to the right. Let's see another example of iMachining 3D savings in steel. Again, 81% saving on this part you see here on the right. Let's see here an example of iMachining 3D cutting of a 3D surfaced part. It's a mold part. See again, he's going to do the whole depth in 2 steps. In the beginning, the roughing. As I said, we always try to use the maximum depth of the flute, of the tool. Now it's doing the step up. As I said, according to the scallop defined by the user, we do the step up. And you notice we only cut in the areas that needs cutting. We don't go all around like in other technologies. We just do the step up in areas that has rest material and had to be cut during the step up. Here we see again an example of a combination of iMachining 3D with simultaneous 5-axis cutting. By the way, Sitecam today have one of the best, highest simultaneous 5-axis product in the market. So let's see here the cutting of this part. And as I said, we start with iMachining 3D to do the roughing, and then we use the simultaneous 5-axis for the finish. We are doing here the machining of an impeller. Again, the trademark of iMachining, it goes very deep for the roughing, using the full depth of the flute. As you see in this, because of the length of the tool, it will do it in 2 steps, the roughing with iMachining 3D. Here is doing the rest roughing. Now it's doing the step up, as I said, according to the scallop defined by the user. And as I said again, the step up is only done where it's needed, where there is rest material to be taken out. And now we start with the finish using simultaneous 5-axis cutting. So now I come to a very interesting issue. Many companies, other CAM companies, say they have similar technologies to iMachining. Actually, iMachining is unique, and I'm going to show you now why. We are going to compare iMachining to VoluMill, which is a model used by many of our CAM competitors, Dynamic Mill, that's Mastercam technology, Adaptive Roughing, that's NXCAM technology, Profit Milling is Esprit, and TrueMill of SolidCAM. Okay, let's compare now according to certain subjects. First, patents. iMachining has many patents, as I showed before. None of the others any patent, only TrueMill, and you know SolidCAM today is not in such a good situation in the market. Now, what is unique about iMachining is the main technological approach. We guarantee constant cutting force on the tool, all along the tool path. The others like volume mill, have constant step over. Dynamic mill and adaptive roughing have constant engagement angle. And again, profit milling, constant step over, and again, tool mill, constant engagement angle. None of them has something similar to our constant cutting force technology. So we are the only ones who are able, as I showed before, to vary the cutting angle as needed along the toolpath and to vary the feed, always, as I said, to make sure that we have constant cutting force on the tool. As you see, none of the others can do that. We have also maximum morph spirals. And as I said, morph spirals are the most efficient toolpath. We have excellent thin wall handling. None of the others can do that. Let's continue. We are the only ones who have a technology result. With the others, you have to guess still the feeds and speeds. I would say we have the shortest learning curve. In cycle time, we had many benchmarks against our competitors, and we always had the fastest cutting, the shortest cycle time. We are the only ones who can do in iMachining 2D the complete process, roughing, rest roughing, and finishing. And because of the combination of all these advantages, we could guarantee you first part success, very important many times. Now, I want to say that we have something very interesting also. We have integrated our iMachining technology inside NXCAM. There's many NXCAM users in the world, and they can all benefit now by having iMachining 2D and 3D fully integrated in their product with the same user interface they are used to. So I recommend anybody using NXCAM today iMachining. He will save a lot in his cost because of the cycle time savings and tool life savings. Last but not least, actually, iMachining guarantees reduced CNC machine wear. You see, the iMachining toolpath, combined with the optimum cutting conditions provided by a technology result, ensure constant load on the tool in any situation. So iMachining makes sure that the constant load on the tool will be such that the spindle load will range, let's say, from 4% to 17% of the maximum possible spindle power. Amazing, right? You see the machine working so fast, and still you see the spindle load is maybe 17%. Actually, few machine tool companies have checked iMachining, for example, Hermela in Germany, and they confirmed what we said also about our savings and our important contribution to machine tool life. Again, also Makino in Japan have tested iMachining and came to the same conclusions. Now I want to talk a few words about our SolidCAM 2021 version, which we have released this year, and which is, we call it our latest and greatest. By the way, this week we have released SolidCAM 2021 SP3, and I recommend every customer of SolidCAM on subscription to get this amazing version. Some of the highlights of SolidCAM 2021, we support complex tool assemblies. In the SolidCAM new tool table, we support multi-body holders and multi-tool assemblies. This is important for complex mill turn and Swiss machines. We have also developed a completely new simulator in SolidCAM 2021 with amazing graphics and functionality. Here you see an example of our simulator for a Swiss type machine and for 3-axis milling. And this simulator is very important for people who are trying to program multi-channel CNC machines. For multi-channel CNC machines, you need to have the best CAM programming and also a multi-channel simulator to see what's happening in the machine. And we are the only people who could provide such an advanced simulator for multi-channel CNC machines. Now, let's go back again and talk about mill turn. Today, SolidCAM is the perfect solution for multi-turret and multi-spindle CNC machines with ultimate programming ease of use, flexibility, and configurability. And obviously, SolidCAM completely supports Swiss-type machine, including multi-channel synchronization. I want to talk a little more about support of Swiss machines. Why does Swiss-type machine customers need CAM? Because in the past, what they were doing is mainly programming, G-code programming right on the Swiss machine. But in the past, they were doing the same part for a couple of months. These days, I've seen customers using the Swiss-type machines do 3-4 new parts every week. So not only they are doing more parts, but parts themselves are becoming more complex. The Swiss machines themselves are getting more complex. So programming and managing sync codes and access patterns for multi-channel machines has become very hard to do with G-code. And again, if you are programming with G-code, you don't have any simulation or verification of the toolpath, which is really crucial. So any Swiss-type machine user doing today programming by G-code has to really upgrade himself, because if he needs to find, if he has one programmer doing this programming with G-code and this programmer quits, it will be nearly impossible to find a new one to train and do this Swiss-type programming manually by G-code. So by using the SolidCAM Swiss-type modules, the CAM programmer works significantly faster and becomes much more productive. SolidCAM supports all the functions today for Swiss-type machines, including multi-channel synchronization, as I said. Now I'm talking to you as SolidCAM resellers. You have the #1 Swiss-type product in SolidCAM today. So if you want to be the #1 in Swiss-type sales and support, you need to have a Swiss CNC expert. But if you don't have such a Swiss CNC expert today, we are giving very good training, task-based training, to any technical staff of our resellers and branches. We have a great trainer, Marina Vilkina, who is expert in this type of machines and kinematics of mill-turn machines and in post-processors, and she will give your staff the best training. It's task-based training, which basically she sends the person doing the training videos to watch and then tasks to do, and then he answers through videos also. What's the advantage of this? He can do it in his own time. There's no specific time that he has to sit in front of the computer. He can do it in his own time. And we have trained till now about 50 of our technical staff and reseller staff worldwide. Second, obviously, you need to find prospects that have Swiss CNC. And today what's happening, many of our existing customers are suddenly introducing Swiss-type machines. So you can find such customers, either existing customers who were doing milling and turning, and now they introduce Swiss-type. And also we found customers who were using SolidCAM for milling and turning and still doing manual G-code for their Swiss-type machines. And all these customers are now buying our Swiss-type solution. Obviously, you could go to a new customer who's using one of our competitors, like PartMaker or Esprit or GipsCAM, and show him the power of advantage of SolidCAM and move him to our product. Today we have proven post-processors in our database for all Swiss-type machines. And remember, you have also to give good training to such a customer. Here an example of one customer who bought our Swiss-type solution. They were a long-time user of SolidCAM for milling and turning. And they were using first GipsCAM to do the programming of their Swiss machines, and then they used Esprit. In the end, when we showed them the power of SolidCAM, they took SolidCAM Swiss solution also for their Swiss machines, and now they are very happy doing many parts every week, programming new parts for their Swiss CNCs. Today we have post-processors for all needed CNC machines, including Star, Citizen, Tornos, Hanwha, Tsugami, and whatever is needed. Our technical team in Serbia, managed by Daniel Durica, can assist you as a reseller to make any new post that you need. Something very interesting in SolidCAM 2021 is also our Turbo HSR, HSM multi-core support. We use 64-bit calculation and multi-core support, as I said. So the speed of calculation, both HSR and SM, increases dramatically as the number of cores increase. Very important, the calculation time for these technologies. And also, we have released additional important functionality for our simultaneous 5-axis, including edge braking, edge trimming, and auto 3+2 roughing. We have done many webinars on these functionalities, and you could watch them in our website. Now I want to talk about something interesting about the SolidCAM company. We say SolidCAM today is a strong, independent, customer-focused CAM company providing a complete CAM system. With our powerful customer-centric R&D, we keep supporting our CNC customers up to the most complex mill turns and Swiss CNCs. So while most of the other CAM systems have sold out to bigger companies, as you have been hearing all along in the last few years, including the latest sale just a month ago, SolidCAM will always be independent and won't compromise our dedicated mission to provide the best CAM products and service to our customers. So, our prospects for any customer today buying a new CAM system today or replacing a current CAM, SolidCAM offers the most advanced, stable, easy to use and to learn, and best well-supported CAM solution. We say it shortly, SolidCAM is the future of CAM. And again, I want to repeat, it's not only about product, it's also about the service. We provide today, through our branches, affiliates, and resellers, the best SolidCAM 5-star support, both for training, technical support, and post-processor support. We have the best CAM teams doing that for all our customers. So we are proud we have this combination of the best product and the best service. Let me talk a little about what are our major new projects coming. As I said, today we are the most advanced in the technologies of mill turn and Swiss type, and we are always doing the next phases to support these complex machines. We are developing a completely new concept, we call it the CAM project, where we could handle multi-CAM parts on multi-CNC machines. You see, on a tombstone, there is multi-CAM parts, but we are doing further than that. We can do support for multi-CAM parts on multi-CNC machines. This will be a unique feature of SolidCAM versus all competitors. Next, we are developing the eye-turning technology. This is a revolutionary turning toolpath and wizard that will create an amazing results in turning like eye machining does in milling. So by having both eventually eye machining and eye turning, for people doing mill turn, you benefit from reducing the milling time and the turning time and obviously increase tool life. Also, our tool sheet, we are upgrading it and we have developed a web-based configurator for new setup sheet. I will be talking a little more about it later. We are introducing SolidCAM Nesting, which was requested by some customers. As I said, Somekh will be providing soon full CNC machine simulation, and this will be also available through SolidCAM. And the last two, our Solid CNC and Solid Flow. I'm going to talk now more about each one of these products. First, let's talk about the setup sheet. The setup sheet that will be coming in SolidCAM 2022 is a new version, much better version of our current Excel-based tool sheet. And we have developed a web-based configurator, which is an online database of predefined templates. You see, people want different type of setup sheets, so they create templates. And using the configurator, you can easily customize these templates and then use them to create the setup sheets. Again, a great tool for the operator, in addition to the shop floor editor and simulator. Here is an example of one screen in the web-based configurator where you could define the contents of the setup sheet for a specific template. Now let's talk about Solid CNC. You see, we said, okay, we have this 20,000 customers using SolidCAM and happy with it. What can we do to help them get more jobs for the CNC machine shop? So we decided to create Solid CNC, which is a marketplace for CNC jobs. It's a web-based website and application where all of you SolidCAM customers could register and put the data about your machine shop and your machines. But there's only one condition that you register there. You need to be on valid subscription and to have iMachining 2D and 3D. You see, only if you have our latest version, SolidCAM 2021, and you have iMachining 2D and 3D, we know that you will give the best quote to any job taker. So if you go on subscription and buy iMachining 2D and 3D, you could be registered in our Solid CNC marketplace. And by the way, we are going to do a lot of marketing for this Solid CNC marketplace so that job takers can find you there. This is an example of some of the screens of Solid CNC. Here, you as a customer registering, you select the industry type you want to support, the workshop capabilities that you have. You could enter the information about your CNC machines, and so that any job taker can look at what the capabilities you have. And as I said, the CNC job givers who are looking for the best CNC machine shop that can do their CNC work, they could come to this marketplace and look for you according to CNC work type, capacity of your CNC machine, geographical location. Somebody could be in a different geography, but he wants to do work in another geography. So when they find a suitable CNC machine shop, they will start to do put their data on the Solid CNC marketplace and ask for quotation. Here again an example of a job taker defining what kind of industry type he wants the customer doing his work do, and then he will upload his model data. It could be a SolidWorks model or a STEP model, and give additional information about what he needs in his specific job. Now we come to our next amazing product, SolidFlow. Why did we come up with the idea of such a product? You see, we studied what you need, you our customers in CNC machine shops. What can we provide you that will get you better production in your machine shop? And we have found out, talking to many potential customers, that the scheduling, I mean existing customers, but potential customers for SolidFlow, that one of their main problems is to do good scheduling of the CNC jobs in their machine shop. And checking all what's available in the market, we have found an amazing technology developed in the United States called Protected Flow Manufacturing by a company called Lilyworks that has been dealing with ERP and scheduling for nearly 40 years. And we have created a partnership for them where we OEM their protected flow manufacturing technology, and we're offering to all of you as our product called SolidFlow. So what does SolidFlow do? Let's have a look. What are the problems facing you today to enhance the performance in your production? First, low on-time delivery percentage of your jobs. Long lead times. High work in process inventory. Too many jobs working simultaneously. lots of expediting when you feel that you are going to go past the due date and you have to expedite in the weekends or at nights. You get also, as a result of all of this, frustrated sales and customer service staff. You are possibly losing a new business or even existing customers unhappy with the delays. And as a result of all of this, you get cash flow issues. If you don't fill the job in time, you don't want to get the cash. Why is it so hard to improve all these parameters? Let's see, for example, how many work orders or jobs are you managing at once? 10, 50, 100? Actually, it depends on the size of your machine shop, of the type of the work you do. And also, not only how many jobs, how many operations in each one of these jobs. Here's an example of a job with about 10 operations. And also, you could have not only one level, but multi-level sub-assemblies with dependencies. It's a much more complicated situation. So, you all have limited internal resources, let's face it. A limited number of CNC machines, of operators, of tooling, of material. And many times also you need external resources, such as heat treating, plating, anodizing. So managing production and improving production performance is a very complex problem. Getting all those orders out by their respective due date is hard. I've asked people, they say, we are always late. And managing production is very difficult, wildly variable. You know, problems happen, things happen in the CNC machine. And there is a lot of moving parts in this process. So what have been people doing till now to do some scheduling? Some people were using these whiteboards. You see them in a machine shop with all these papers. Very not optimal way to do it. Other people have been using a lot of spreadsheets to do the scheduling. And people using ERP system, these ERP systems usually provide what I call traditional finite scheduling tools. I will talk about it more later, why they are not so successful, these traditional finite scheduling tools. So why the struggle with spreadsheet and whiteboard is difficult? Because they are very time-consuming to maintain. Things happen and you have to change them. Just trying to establish what's need to be worked on today or this week, and you don't have not much future visibility to plan for the future jobs. Also, whenever there are changes, you require frequent updating if the priorities are to be accurate. So many times you don't update and then your spreadsheet has become obsolete. And especially in case of whiteboards, there's only a single copy in the whole machine shop. So hard to share across the organization. And you want the information about the jobs to be available to everybody in the organization to get the maximum production. Again, as I said, existing ERP systems also have some scheduling. And people using ERP expect to get from it an optimized schedule. However, this optimal solution doesn't exist. It simply cannot be computed. You can read more about it. So the traditional method used in ERP is based on a capacity loading algorithm. So the schedule is based on the capacity available, but it does not reflect how production actually happens. Variability in manufacturing makes the result of the scheduling program in ERP quite obsolete for execution. Also, all ERP systems use the due date of the job as a priority. And this skews the true priority, especially in high mix, low volume type of work, for example, in CNC machine shops, which is doing too many new parts with few pieces in each part. So with traditional scheduling, you must start with very accurate estimated setup run times. And these times become the schedule. And actually, the more sophisticated the schedule program in the ERP, the more mysterious is its black box. So the shop staff operations don't understand where these priorities are coming from. And then they neglect it and they do what they know what to do through using spreadsheets. So what we found out that most machine shops who have an ERP system really don't use the scheduling of the ERP system and instead still use spreadsheets. So how do we improve production performance? What we need is a new approach. We want to get rid of whiteboards, spreadsheets, and traditional finite scheduling, and focus on something called the flow. What do I mean by this? What is the flow? All benefits in the machine shop will be directly related to the speed of the flow of information and materials. The question is, how can we publish the right information to where the work is happening so that production can make the right decisions that will enable improved speed of flow? So, the benefits of speeding the flow of materials are, first, you get high on-time delivery percentage, short lead times, low work in process inventory. Rarely you need expediting. You get happy sales customer service staff. Also, you can win new business and strengthen the relationship with existing customers. And then the final advantage, cash flow speeds up as well. As jobs go out, you get better cash flow. So how does SolidFlow achieve this? By establishing real-time shop floor priorities. As you see here, there are different colors. There are some jobs that have red color, which means they have higher priority, yellow or green. And there is a real-time shop floor status for each job that is being done in the machine shop. Also, you have web-based predictive analytics. As we said, we want to know what's going to happen. When is this job predicted to finish? Which is based on all the other jobs in production, calendar time constraints, CNC machine capacity, operator capacity, material constraints, tooling constraints. So SolidFlow can provide you with predictive analytics to get the answer to these questions. And you are always seeing what's happening in your machine shop, in all the jobs. As you see, some of them are red, some yellow, and some are green. And this way you know what is the real-time priority. So always use the right priority and not a due date, which means you cannot say if some job is going to be needed in 2 months, you should never start on it now, but start on it only 2 weeks before that. Not always the due date should be the deciding factor when you start a certain job. And SolidFlow helps you make the right decision. It always checks what is the actual work completed, what is the work remaining, and what is the due date. So it can know what is the time protection remaining. And then it calculates something called the threat level priority, which is the percentage of work remaining divided by percentage of time buffer remaining. So the higher the threat level priority of the job, it becomes more urgent to start on it. So for every job in the system, SolidFlow calculates all the time this changing threat level priority. This is not something constant. It's always changing according to what's happening in your machine shop. Now, if you have currently an existing ERP system, and many of our customers have an existing ERP system, SolidFlow can be integrated with their current ERP. As you see here in this diagram, SolidCAM can give information to SolidFlow, for example, tool table information. SolidFlow can connect to the ERP, and by connecting to the ERP, SolidFlow pulls your job and work orders from your ERP. So what happens if you don't have an ERP? In that case, it could take the data from your spreadsheet directly into SolidFlow and then continue to manage it through SolidFlow. But if you have an ERP, you can get a direct integration to your ERP via something called the integration platform, and you get automatic scheduled updates every few minutes or hours. As the data are updated in the ERP, they are updated also in SolidFlow. So now, using SolidFlow, we can answer the fundamentals of improving production. What job, work order should we be working on right now, shop-wide or by department, resource, machine, or person? When will I have material for this or any job? Raw materials, fabricated materials, fabricated components, manufactured components, sub-assemblies. Where are the jobs? How are they progressing? How do I tell my customer when they are going to receive their order with confidence? So in the end, SolidFlow provides these great advantages. Greater visibility of operational information to improve flow. Higher on-time delivery percentage. Very important for every CNC machine shop. Lower work in process inventory. Shorter manufacturing lead times. And I could tell you, SolidFlow implements quickly. You could see fast return on investment. You will see personnel time and cost savings, and also improved added value revenue margin. So now to summarize, what is the main premise of SolidFlow is the focus on the flow, making it visible and taking the right decisions to speed it. So in the end result, as CNC jobs flow smoothly out, money flows smoothly in. After giving you this explanation of what is SolidFlow, now I would like Mark Lilly, the CEO and president of LillyWorks, that developed this amazing PFM technology, to give us his own introduction about this technology. Thank you for watching.